What's up, and welcome to Unit 2. We are talking matrices. We're starting off with matrix operations. Two goals today: defining a matrix and performing addition, subtraction, and scalar multiplication. This is a great way, I think, to start. Super easy. If you can add, subtract, and do basic multiplication, you are going to be in great shape. So, starting off with some vocabulary, a matrix is a rectangular arrangement of numbers in rows and columns. The dimensions of a matrix are given by row times column, usually written as m times n. That's going to be important when we jump into not scalar multiplication, but matrix multiplication. So, the entries or the elements are each individual number of the matrix. Equal matrices have the same dimensions, and each corresponding element is the exact same. So starting down here with example number 1. Super blurry, super light. Love to see it. Tell whether the following matrices are equal or not. So you're just looking at the corresponding elements. So 2.5 and 5 halves. Those are the same. So far we are good. -1 and -1. So far, these two matrices are equal. -0.2 and -1/5. Those are the exact same thing. And last but not least, 3 and 3. Those are equal. So these are equal matrices, because the corresponding parts are the exact same. So second example, top left is 1 over here, top left is 0 over here. I can stop right there because they are not the same number. These are not equal. By the way, I should go back to the letter A here. This would be a 2 by 2 matrix. This would also be a 2 by 2 matrix. We have 2 rows and 2 columns. 2 rows, 2 columns. Same thing here. These are both 2 by 2s, 2 rows, 2 columns, which is a requirement for equal matrices. But again, in letter B, the top left corners are not the same number. Therefore, they are not equal. So let's get into something a little bit more difficult. Letter A here. Perform the indicated operation, which, hopefully we can see right here, is addition. First of all, check to make sure they're the same size. You can only add and subtract the matrices that are the same size. So right now we have a 1, 2, 3 rows and 1 column. So this is a 3 by 1. This is also a 1, 2, 3 by 1. So we can go ahead and add 3 rows, 1 column, 3 rows, 1 column. So here's how it works. You just add the corresponding elements. 0 plus 1. Should probably set up my answer matrix here. So 0 plus 1 is 1. 4 plus -9 is -5. And 3 plus 8 is 11. So you're just adding the corresponding elements, the elements that are in the same spot on the matrices. Letter B. Here we have another 2 by 2, and we're subtracting another 2 by 2. So we are good to go as far as the dimensions. They are the same. Our operation here is subtraction. So same idea, subtract the corresponding elements. So top left is 3, minus top left over here is 2. So 3 minus 2 is 1. 3 minus 0 is 3. 9 minus -3. Now be careful with this. 9 minus -3. We're going to end up with 2 negative signs back to back, which we could turn into addition. So really this becomes 9 plus 3, which is 12. And then last but not least, we have -5 minus 5. So if we start at -5 and we take away 5 more, we end up at -10. So just subtract the corresponding elements or add, and you're good to go. Letter C, what we have here is a 1 by 2, and a 2 by 2 matrix. Because they're not the same size, this is not possible. So they have to be the same size, same dimensions in order to add or subtract. Scalar multiplication. This is just taking the number on the outside and multiplying it by every single number on the inside. That's it. This is different from matrix multiplication. That'll be a different video. But let's go ahead and start. So, 6 times 2 would be 12. 6 times negative 3 is negative 18. 6 times 8, 48. And 6 times 4 is 24. And that is scalar multiplication. These questions can get a little more difficult, obviously. If you look at letter B, we have some scalar multiplication out front. And we also have to add. So, first of all, to make sure we can even add, we can always do scalar multiplication. But to make sure we can add, we have a three rows by 2 columns, and we have a 3-row by 2 column matrix there. So we can go ahead and add these. Just like order of operations, you're going to do multiplication first, and then we're going to add. So let's do this. Start with the scalar multiplication. So negative 1 times 4 is negative 4. Negative 1 times negative 7 is positive 7. That's negative 3. That's also negative 3. That would be negative 2 and positive 9. So I did the scalar multiplication first. Now I can go ahead and add this second matrix. I'm just rewriting it down here so I don't have to jump around to do my addition. And same thing, add the corresponding parts. So let me get my answer matrix set up. Starting with the top left, negative 4 plus 3 excuse me, is negative 1. 7 plus 6 is 13. Negative 3, now we're going middle left. Negative 3 plus 9 is 6. Then we have negative 3 plus negative 8. We end up with negative 11. And then we have negative 2 plus 1, which is negative 1. And finally, 9 plus negative 4 is 5. So that's kind of just how you do a combination of both. Again, it comes back to order of operations, PEMDAS, parentheses, exponents, the multiplication. That would be scalar multiplication in this case until we start matrix multiplication. And then we go ahead and add. And as far as matrix operations go, this is about as difficult as I can make it. We'll take a look at one more here. Example number 4. It says perform or solve the matrix equation for x and y. So just a little bit different. But again, back to order of operations, we have parentheses now. So we have to start there. So what this is telling us to do, we have parentheses, and then we have a 4 on the outside. So we have to do the scalar multiplication to everything here in the first matrix and everything in the second matrix. So I'm going to erase all those lines, but I'm just showing you. You multiply everything in those two matrices by 4. So let's go ahead and erase that so it doesn't look so gross. And let's go ahead and multiply. So jump down here. 4 times 8, 32, 0, negative 4. 4 times 2y is 8y. Plus, now we also have to multiply everything here by 4. 16, negative 8x, 4 and 24 equals 48, negative 48, 0, and, 8. Fix those quick. All right, so we followed the first step in the order of operations, parentheses. There is no exponents. The parentheses asked us to multiply, so we took care of that. Division, addition. We have adding that we can do here. So let's go ahead and do that in the next step. So add the corresponding parts. 38 plus 16 is let's see. Why did I write 38? Oh boy. Let's fix that. Goodness. 32. And what do we have here? 0. There we go. That makes a little more sense. My apologies. 32 plus 16 is 48. 48, yep. 0 plus negative 8x is negative 8x. That came from right there. Negative 4 plus 4 is 0. And 8y plus 24 is just 8y plus 24. You can't actually add them together. Now, the reason why I knew that that first one was a mistake was when I added those two numbers, I had to get 48. Because if you look at what this, the left matrix is equal to the right matrix, so I have to have the same numbers in the same boxes. So I wasn't going to get 48 there, so I knew I made a mistake somewhere. But now it does say to solve for x and y. So we got to use that idea that these the corresponding elements are the same. So 48 should equal 48, which is true, so we're good to go. But also, negative 8x has to equal negative 48. So just kind of off to the side, we're going to set up a little equation to solve for x. We're saying that negative 8x equals negative 48 because these two should be the same, which is true. Divide both sides by negative 8, we get x equals 6. So we solve for x there. There's one answer. Okay, just continuing our check, we should have 0 equals 0, and we do. And then last but not least, we have 8y plus 24 equals 8. So again, that has to be true because these two matrices are equal. We want to go off to the side and set up another equation. So 8y plus 24 equals 8. And then we're just going to use a little algebra to solve this. So 8y equals negative 16, divide by 8, and y should equal negative 2. So using the idea of equal matrices, meaning the corresponding, like letter A here, the corresponding parts have to be the same. That's what we're saying here. Because of that, we could solve for x and y. Example 5 will skip, but it just asks you to subtract this one. So you take this one, write it down first, and then subtract this one off of it. It's just the same idea as basic subtraction, but with bigger numbers.